Asymptotes are extensively studied in calculus, but you do need to know a few things coming in. Whenever we talk about vertical or horizontal asymptotes, the first thing you need to do is look at your function y is p over q. And in general, p and q are polynomials. And you want to go on and factor these to start with and cross out any common terms. You want to analyze vertical and horizontal asymptotes with your bare bones function. Now, anything that crosses out whenever you have a zero in the denominator, that's going to be a whole. Now, once you've done this, you've factored all the common terms out, you're going to set q equal to 0. And this will give you your vertical asymptotes. Your horizontal asymptotes, you look at the highest degree of the coefficient of the numerator and the highest degree of the coefficient in the denominator. If the highest degree of the coefficient in the numerator is greater than the denominator, then you don't have any asymptotes, it just shoots off to infinity. If the highest degree of the denominator is greater than the numerator, then you do have an asymptote, and that is y equals 0. And this is if the degree of the denominator is greater than the degree of the numerator. Now, if they're the same, then you're going to wind up with an asymptote equal to the ratio of the coefficients. So if I have y is 3x squared plus 4x plus 3 divided by 2x squared plus 1, if we look at the coefficients, this will have an asymptote at y equals 3/2. All you have to do is look at the highest two for asymptotes. Now let's look at this function right here and see if we can figure out where the asymptotes are. Minus x squared divided by x squared plus x, minus x plus minus 6. The first thing you always do is factor. So this is minus x squared divided by x minus 3, x plus 2. So I always do horizontal asymptotes first. The horizontal asymptotes will be at x equal 3 and x equal -2. And lo and behold, that is what I find on my graph, -2. Now I want to look at my vertical asymptotes. To do that, I only need to look at the highest coefficient. So for that, that will be y equals -1 over 1 or -1. Now we're not trying to do detailed graphing at this point in time. All we're trying to do is find the asymptotes. What about this function right here? The first thing I want to do is graph it, or excuse me, factor it. So this is x plus 1. Now, what does the denominator become? X minus 3 times x plus 1. Now you see these two terms go away. So that tells me there's a whole at x plus 1 equals 0 or at x equal -1. So that's the whole. But it's not an asymptote. So another way to write the function is y is 3 divided by x minus 3. So where am I going to have a horizontal asymptote? I will have a horizontal asymptote. Let me look at my highest power. And that is going to be at y equals 0. I'm going to have some sort of horizontal asymptote. A vertical asymptote will occur when x minus 3 is 0 or when x is equal to 3. And I do usually do the vertical asymptotes first before I do the horizontal. Now finally, let's look at y equals 2x squared minus 4x divided by x squared plus 4. Now, let me look at for any vertical asymptotes, and there are none. Because I can't ever make x squared plus 4 equal to 0. But I can factor the numerator anyway. If I factor out an x, this becomes x minus 2 divided by x squared plus 4. Now I want to do this in general because this will help me find zeros, etc. I see that the function is 0 at 0 and at 2. All right. Now, in order to find the horizontal asymptotes, all I need to do is look at the leading coefficients. So my horizontal asymptotes are at y equals 2 over 1 or y equals 2.